Our next video will be focusing on the same example, but now we're going to solve it using node analysis and then solve it using Cramer's rule. Okay, not analysis but solve using Cramer's rule to get the transfer function. So the circuit is exactly the same as the video for the mesh analysis just now. Okay, so your first step is convert the time domain circuit into an S domain. So the circuit in purple is the S domain circuit. Okay, so in node analysis, we need to find the node, the equation for the nodes. Okay, so the nodes that we're going to mark here will be node 1 and node 2. Okay, so this will be our node 1. Node 1, let's say the voltage at node 1, we will call it as V1S. And then this is our node 2. Okay, so we don't have many options. We just have these two nodes that we can use. Okay, so this is our node 2, and if you notice, okay, this line at the bottom here is connected to the negative power supply, meaning that this is the part where you ground it. Okay, it is grounded, so meaning that this connection here, if it's grounded, okay, so if it's grounded, because it is directly connected to your negative supply, so meaning that the voltage at this the voltage at this line is 0 volt. Okay, so at node number 2, okay, this is the voltage across the output resistor, meaning that this second node is actually a V0S. Okay, so this is the case if you have the connection directly goes to the negative of the power supply. Okay, so it should look like this, meaning that the line below here is grounded 0 volt. So the node number 2 will become V0S. Next one, we want to draw the current arrow for node number 1. You have one current going in and two current going out. Okay, for the second node, you have one current going in and one current going out. Okay, so in node analysis, we need to find the sum of current going into a node equals to the sum of current out of the node. So this is the fundamental of nodal analysis. Okay, it is Kirchhoff's current law. Okay, so let's find the equation for node 1. Okay, for node 1, we have one current going in. So V1S minus Vs divided by 2. Okay, so V1S minus Vs, because at this point, this node here, it is Vs. Okay, the potential at this node here is Vs. Okay, there's no other component after the Vs. Okay, so V1S minus Vs over 2, which is voltage drop divided by impedance, you will get current. Okay, so current in, only one, and then you have two current out. So the second one is the first current out. Let's take this 0. This point is 0 volt. 0 minus V1S divided by 1 over 2S plus, okay, the second current out from the node is V0S minus V1S divided by 2S. Okay, so it is voltage drop divided by impedance. Okay, if you notice, my arrangement is probably opposite what you have learned in circuit theory. Okay, if in circuit theory, you might be doing Vs minus V1S divided by 2 equals to V1S minus 0 over 1 over 2S plus V1S minus V0S over 2S. You can also use that arrangement. There's nothing wrong. It's just that the equation is in node 2 have to follow that format as well. Okay, so it needs to be synchronized. So if you're using that method, go ahead, there's no problem, you will get the same solution. Okay, so right now I'm going to arrange this equation such that the Vs will be on the left hand side. So I will have negative Vs over 2 equals to negative V1s. Okay, so this one is actually negative 2s V1s, okay, because it is divided by 1 over 2s, plus I'm going to split all of these terms because we're going to put similar terms together. Okay, so negative Vs over 2 equals to negative 2s V1s plus V naught s over 2s minus V1s over 2s minus V1s over 2. Don't forget the terms on the left that has been brought to the right. Okay, so now put similar terms together, which is you have so many V1s, so please put them together in bracket. Negative 2s minus 1 over 2s. Okay, so let me skip this first, meaning that, okay, we're going to remove that negative 1 over 2 on the left hand term. Okay, so Vs, so that it will be easier for us later on. So Vs equals to 4s V1s minus minus V naught s over over s plus V1s over s plus V1s. Okay, this should be it. So I am multiplying both sides with 2 so that I can reduce the equation. Okay, that sounds like it looks okay. So now put the similar terms together. So 4s plus 1 over s plus 1 I1. Oops, sorry, it's not I, it's V1s minus V naught s over s. Okay, so as I mentioned, you need to make sure that those equation with a lot of terms in bracket, you need to make sure the denominator is the same so that it makes your solution looks so that it's easier to solve later on. Okay, so this term here that is for V1s will become 4x squared plus s plus 1 divided by s. V1s minus V naught s over s. So this is equation 1. Okay, I might have written this a bit too big, it's fine. Okay, so next we're going to go to node number 2. Okay, for node number 2, we only have one current in and one current out. So current in, V naught s minus V1s divided by 2s equals to 0 minus V naught s over 5. Okay, now since we don't have any power supply terms in here, so I want you to bring all the equation on the left hand side to the right hand side. Okay, so meaning that on the left hand side you will be left with 0. Okay, so this one will become negative. Okay, so please make sure your arrangement for the terms is the same as in equation 1. In equation 1, I put the V1 term first and then V naught s. So follow that arrangement. So meaning that V1 term first. Okay, and then we have, okay, so V naught s in bracket 1 over 5 plus 1 over 2s v naught s. Okay, so make sure the denominator is the same. So you will get v1s over 2s minus, both should be multiplied by, to make sure that denominator is 10s, yeah, over 10s. So it become 2, oops, wait. It will become 2s, okay, plus 5. Okay, so since we have a 0 on the left hand side, meaning that we can actually make sure the denominator for both v1 and v0 term the same, and then just cancel off that denominator. Okay, so that's a beauty when you have an equation which equals to 0. You can actually remove that denominator. Given that, you need to make sure denominator is the same. Okay, so it will become 5v1s minus, in bracket, 2s plus 5 v0 s. Okay, so it is reduced to this. So this is equation number 2. So now you have two equations, equation 1 and equation 2. Okay, so again, this is your first step, second step. Okay, so now we're going to put them in a matrix form. Okay, so this equation and this equation, put it in matrix form. So it will be the first matrix 2 by 1 is given by Vs and 0, which is from this term. Okay, equals to, okay, so this matrix is, look at the first equation. So it is 4s squared plus s plus 1 divided by s minus v naught s over s. Okay, minus 1 over s. Okay, so this is multiplied by v1s, v naught s. Okay, so this is for equation for the top row is equivalent to equation 1. So going to the second equation, 0 equals to 5 v1s and then minus 2s plus 5. Okay, so now you have your 2 by 2 matrix that we're going to solve using Cramer's rule. So this is the 2 by 2 matrix. Okay, so if you're using node analysis, directly you can find v naught s. Okay, so directly you can find v naught s. You don't have to find what is relation between current and voltage, because there's no need, because you are already in the voltage term, which is the beauty of using node analysis. Right, so we're going to find v naught s. Okay, so v naught s is the bottom or the second term in this 2 by 1 matrix. Okay, so it is here. Okay, so meaning that this matrix here, the 2 by 2 matrix, okay, the second column is the term that is multiplied with the v naught s. So meaning that using Cramer's rule, okay, we have a special matrix which the second column will be replaced by the left hand side matrix. Okay, so for to find v naught s, we need to find determinant for the special matrix divided by determinant of the original matrix. So let's put the equation first. Okay, so this is our special matrix. Please notice that my second column is actually being replaced with the left hand side matrix. Okay, and then the bottom matrix remain the same. So this is the what is going on? So this is the symbol This is the symbol. The straight line is the symbol for determinant, and you should write it correctly lah, yeah. Okay, so let's find the determinant for the top matrix. Oops, let's use blue. Okay, so here determinant is AD minus BC. Okay, so meaning that the A is 4s squared plus s plus 1 divided by s multiplied by 0 minus Vs multiplied by 5. Okay, so the first term is 0, so you will get negative 5 Vs is the determinant for the top matrix. Okay, next one we're going to find the determinant for the original matrix. So again, AD minus BC. Okay, so for 2 by 2 matrix, AD minus BC is the way to find the determinant. So the A is 4s squared plus s plus 1 divided by s multiplied by, so negative, so I'm going to put negative here, so 2s plus 5. Please, okay, so wrong writing. Sorry. Okay, so don't forget the negative sign so that you don't get the wrong answer. So minus 5 multiplied by negative 1 over s. Okay, so you will get negative in bracket 8s cubed. So you have to expand this equation. You will get 8s cubed plus 22s squared plus 7s plus 5 over s minus, or it will become plus 5 over s. Okay, so remember you still have the negative sign. So expanding this, you will get negative 8s cubed minus 22s squared minus 7s minus 5 over s plus 5 over s. So the second term is also over s, so you can actually combine them and you will end it up with the determinant as negative 8s cubed minus 22s squared minus 7s divided by s, and can be further reduced to negative 8s squared. Oops, sorry, it's no longer an s cubed, so negative 8s squared minus 22s minus 7. So this is the equation for your bottom determinant. Okay, so now from here going to go here lah. Okay, so now that you have the top determinant and bottom determinant for the matrix, okay, we are going to rewrite V naught as equals to, top determinant is negative 5 Vs divided by negative 8s squared minus 22s minus 7. Okay, since we have top and bottom negative sign, so we can reduce that, so it becomes 5 Vs oops, over 8s squared plus 22s plus 7. Okay, so we need to rearrange this equation so that you will get V naught s over Vs equals to 5 over 8s squared plus 22s plus 7. As I mentioned, you need to reduce the s squared 8s squared to s squared, so you need to divide both numerator and denominator with 8. Okay, so it will become 5 over 8 divided by s squared plus 22 over 8s plus 7 over 8. Okay, so putting this into a transfer function form, it should look like this. So in the block, you will have the transfer function 5 over 8 over s squared plus 22 over 8s plus 7 over 8, and this is your final answer. So using both node and mesh analysis and using Cramer's rule, you will be getting the same solution, you will be getting the same answer. Okay.